Hello guys, welcome to my YouTube channel, and today we'll be studying the statistics, that is measure of dispersion. Okay, so some concepts of it and then we'll conclude. Okay, yeah. So measure of dispersion. So there are a few things in measure of dispersion like range, then variance, standard deviation, quartiles, and lastly the interquartile range. Okay, so we'll study these concepts one by one and then we will conclude the lecture. Okay, so what is range here? So basically range decides the the overall range of the data set, like from minimum value to maximum value, how many sample of data is there. Okay, so in this case the range is the simplest measure of dispersion that aims at providing an idea how much the data varies in the data set. Okay, so the range is expressed as a maximum value in the data set minus minimum value. So in this example of 8 numbers, that is 10, 15, 28, 12, 7, 18 and 25, first the data is arranged in ascending order or descending order. Okay, and then we identify the smallest value, or you need not sort the data, just need to identify the smallest and the largest value. So here in this example the smallest is 7 and the largest is 25. So range is calculated by 25 minus 7, that is 18. So the range of data set is 18. Okay, next is variance. So what is variance? So it gives us how data is dispersed in the data set. Okay, so it is a better indicator of dispersion. It describes the deviation of data from each other and from the mean. Okay, so variation for a population of size n can be calculated using the formula this. Okay, sorry, this is for sample and this is for population. Okay, and then this is this table we have to calculate. Okay, so firstly we will understand with the example. Okay, so this is the data, that is 1, 2, 5, 7 and 10. Okay, so its mean is 5. So what we have done here is xi minus nu. So xi minus nu is nothing but mean. Okay, so and xi is the x of I is the original element. So we minus or subtract the mean from the original element and then we square it. Okay, so after squaring it, whatever sum we get, we divided by this number. Okay, so 54 divided by 5, that is 10.8. so that is nothing but the variance. Okay, next is the actual variation of the data from the mean is represented by standard deviation. Okay, so standard deviation is nothing but the square root of variance, you can say. Okay, so in this case the square root of 10.8. okay, that is SD or the standard deviation. Next is the quartiles. So what are quartiles here? So quartiles gives us like 25% of data and then 50 and lastly 75% of data. So quartiles are 3 points in the data set that divide the data set into 4 equal groups. That is, the first quartile is the 25th percentile of the data set, that is the value which is 25% of the data lies. Okay, and the second quartile is the 50th percent, this is also known as median. Okay, and 50% of the data lies below this quartile. And lastly the third quartile, that is 75% of the data set, it gives us the 75%. So here you can see this is the lowest value in case of, like, consider the range from 7 to that number, that is 25, I guess. Okay, so lower quartile is 25%, that means from here till here this is the first quartile, that is Q1, and from here to here it is Q2, and from here to here it is Q3. Okay, and this is the max value. Okay, so these are quartiles. Now lastly the interquartile range is nothing but a Q3 minus Q1. Okay, that gives us interquartile range. Okay, so before interquartile range we will have the examples of quartiles in case of odd values and even values. Okay, so consider the following data set of 7 numbers, that is 4, 8, 10, 12, 15, 16, 20, and then first we need to arrange it in ascending order. So we have arranged it like this. So Q2 is the median. Okay, so first the middle value, that is 12. Okay, so here in case of 7 number, like we directly odd numbers, we directly get the middle value, that is 12. Okay, so directly we get the Q2 here. Okay, so quartile 2 is Q2, that is 12. Okay, so to calculate Q1 what we do is lower of the data set excluding median, so we need to drop this. Okay, like for just this, like for temporary case, and then lower half contains the first 3 numbers, that is 4, 8, 10, right? So since there are an odd number of values, we can find the median of the lower half, that is 8. So directly we can say that this is Q1, and lastly here it is 16, right? That is Q3. In case of odd, it is directly you can give, that is, first the median is of all the data is the Q2, and the median of lower half is the Q1, and median of upper half is the Q3. Okay, so that is how you calculate in case of odd data set. In case of even, what we do is we divide the middle two values and we get it. That is, in this case it is 6 plus 8 divided by 2, that is 8 5 13 14, 14 divided by 2 is 7. Okay, that is Q2. And then in similar case, the lower half and the upper half it is divided. Okay, that is 2 4 6 8. So middle value is 4 plus 6 divided by 2, and here it is, what it is, 12 plus 14. Okay, that is divided by 2. So Q3 is 13 and Q1 is 5. Okay, so this is how you calculate the quartiles. And lastly, the interquartile range. So it is the difference between the quartiles Q3 and the first quartile Q1. Okay, so this range is used to indicate the spread of data and is better measured than range, because min and max used in range are highly volatile in the presence of unusual values, right? So this gives us like the proper analysis of difference between the data, or the upper and the lower portion of the data, that is interquartile range. So it is vastly used to reduce the number of outliers. So outliers are nothing but like whatever values do not match the range of data or dispersion of data. For example, suppose you consider this graph, and here in Q1 and Q2 and Q3, so like if you consider this, so basically here the data lies, right? So in this above 75 and below 25, if there are some values like minimal 1 or 2 values at the extreme position of 75 and 25, and those are considered as outliers. Okay, so quartiles help them identifying. Okay, so that is the use of quartiles. So we studied about measure of dispersion here. So basically dispersion helps us to study and analyze how data is dispersed in entire the data set. Okay, so this is how we calculate dispersion using range, variance, standard deviation, and quartiles and interquartile range. Okay, so hope this helps. So if you learn something from this video, do hit that subscribe button. Until then, take care. Bye bye.